In this video, we will explore the composition of compounds. So we'll start this by calculating the mass of 1 mole of a substance, a compound or a molecule. This is called the molecular weight. We can also call this the formula weight, the molar mass, or the molecular mass. We'll use these interchangeably. And again, this is the mass in grams of 1 mole of molecules or compounds or formula units of whatever it is that we're dealing with. So to do this, we'll start with an example. We'll use water. The molecular formula for water is H2O, as we've seen before, and we want to calculate the molecular weight of water. And if we look at the periodic table, here it is, hydrogen is 1.01 AMUs, and oxygen is 16 AMUs. And remember that our AMUs are different units than our grams per mole, but the values are going to be the same. So if we have a 1 mole of hydrogen, it's going to be 1.01 grams, and if we have 1 mole of oxygen, it's going to be 16 grams. We can use that, and we'll take that back here. We'll say, okay, well, we have hydrogen, that's 1.01 grams per mole, and in H2O, this 2 designates that we have 2 moles of hydrogen per mole of H2O. This can be confusing to some students, but you can think about this in terms of boxes of donuts. Maybe I have 12 boxes of donuts. Okay, so boxes of donuts. And each box of donuts has a dozen. So we have a dozen boxes of donuts, but each box of donuts has a dozen donuts. Okay, so that's the same thing. We have two, so this is the same type of idea, not the same thing. If only hydrogen atoms were donuts. Okay, so we can have 2 moles of hydrogen atoms within 1 mole of water. So we're going to then say, okay, well, we need to multiply this by 2 moles. That will get us the mass from hydrogen in 1 mole of water. Okay, and then oxygen, that was 16 grams per mole, and we have 1 mole of that. Okay, so now we have 2.02 grams of hydrogen and 16.00 grams of oxygen. We simply add these together, and now we should have 18.02 grams of H2O per mole of H2O. This is our molecular weight. You'll see me write this MW. Molecular weight of water is 18.02 grams per mole. Okay. Now you try. Use the periodic table to look up the masses of the constituent atoms for methane. Methane is CH4. And ethanol. Ethanol is, its molecular formula is C2H6O. And then calculate the molecular weight. Great. Hopefully you got these. So we'll do methane really fast together. Carbon is 12.01 grams per mole. And we have 1 of those, so 12.01 grams from carbon. Hydrogen, again, is 1.01 times 4, so we should have 4.04 grams from that. Simply add this together, and now we're at 16.05 grams per mole of CH4, methane. Ethanol, molecular weight. For ethanol, you should have gotten 46.08. If you didn't, come to my office hours and we'll work it together. Now let's look at how to relate the molecular weight or molar mass that we just calculated and the number of moles, the number of molecules of a substance. So we're going to do this just by working this problem. How many molecules of CO2 do I have if the total mass of my pure sample is 10.8 grams? So when we have these types of problems, when we're trying to find how many of something when we're given some other value, that should make you say, hey, we're going to use dimensional analysis. The first thing we do in a dimensional analysis problem is determine what we have been given. That's grams of CO2. And we want to find molecules of CO2. So if we can think about this, we just learned molar mass. So that's likely going to be one of our conversion factors. Let's think about what that can convert between. If we have molecular weight, that's in units of grams per mole, and that's going to be grams per mole of CO2. So we could say, well, if we have grams of CO2, we can use molar mass or molecular weight to go to moles of CO2. Molar mass or molecular weight, same thing. And then from moles, we can go to molecules. We've done that before using Avogadro's number. Great. So our two conversion factors are molecular weight and Avogadro's number. Now we'll set this up. We say 10.8 grams of CO2. Again, just as a reminder, always put your units and what you're looking at. So I'd take points off if you didn't have grams. I'd take points off if you didn't have CO2. The molecular weight of this molecule is 44.009 grams per 1 mole. So now we'll have gotten rid of grams and we'll be in moles. We want to get rid of moles and get molecules. And we know that there are 6.022 times 10 to the 23 molecules in 1 mole. I'm going to give myself a little more room of CO2. So we should have molecules of CO2. Again, we'll just double check, get rid of grams, get rid of moles, get molecules of CO2. And if we put this into our calculator, we should have 1.48 times 10 to the 23 molecules of CO2. 3 sig figs here, 3 sig figs here. This should be a large number because we're in molecules instead of grams. Fantastic.